Hello everyone, my name is Kurosh Parand. In this video, we learn the concept of correlation through three real-world examples in education, healthcare, and business. We also explored how scatter plots help us visually understand relationships between variables, including their direction, strength, and shape. Then we applied correlation in practice using both Excel and Python and saw how to compute the Pearson correlation coefficient. We also understood the Pearson formula and how it works behind the scenes, and finally we discussed the relationship between correlation and covariance. Overall, correlation is a powerful tool that helps us understand relationships in data and support better decision making. Example 1. I am an education analyst and I want to understand whether SAT scores or SAT scores are related to completion rate percentage. Since both variables are numerical, I use Pearson correlation to measure their relationship. Step 1. Start with a question. Suppose I am an education analyst and I want to answer an important question. Is there a relationship between SAT scores and completion rate percentage? So in step 2, introduce the variables. I mentioned that in this example, I have two variables, SAT score and the other is completion rate in terms of percentage. Both variables are numerical. SAT score is a number and a completion rate is also a number expressed as a percentage. Step 3, choose the right method. So now the question becomes, what statistical method should I use? Again, what statistical method should I use? Because both variables are numerical, the correct method is Pearson correlation. This method helps us measure the direction of the relationship, the strength of the relationship. We have two parameters, the direction of the relationship and the strength of the relationship. Step 4, explain Pearson simply. Pearson correlation gives us a value between -1 and 1, interval between -1 and 1, positive 1 plus 1 a strong positive relationship, -1 or -1 a strong negative relationship, and we have 0, no linear relationship between two variables. In this step, we have a data set, for example, and you can see SAT scores and completion rate. For example, group A, we have 900 SAT score is the number, and completion rate in terms of percentage is 60. And for group B, C, D, and E, we have like this. So step 6, interpret the pattern. Now observe the pattern carefully. When SAT score increases from 900, for example, to 1300, you can see completion rate is increasing from 60% to 90%. This shows a positive correlation. It means that higher SAT scores are associated with higher completion rates. So a statistical conclusion is step 7. To measure this relationship precisely, we calculate the Pearson correlation coefficient and we say that R. If the value of R is close to 1 plus 1, it means that the relationship is strong and positive. Please pay attention. Correlation does not mean causation. Step 8, important warning. But remember, again, correlation does not mean causation. SAT scores does not guarantee graduation. What happened? Maybe other factors influence completion rates such as student motivation, financial support, quality of education. Step 9, final conclusion. So in this example, we had two numerical variables. Again, numerical variables. We use Pearson correlation. Again, Pearson correlation. We found a positive relationship. This helps us understand patterns in educational data and support better decision making. Number 2 is this scenario is about the healthcare analysis, glucose level and diabetes rate, type 2 diabetes. For example, I am a data scientist analyzing diabetes data, and I want to understand whether glucose level is related to diabetes rate or no. Since both variables are numerical, I use Pearson correlation. Again, Pearson correlation. Higher glucose levels are associated with higher diabetes rates. Using Pearson correlation, we can measure how strong this relationship is. But remember, correlation does not prove causation. Step 1, start with a question. Now let's move to the healthcare. Suppose I am a data scientist working on diabetes prediction. My question is there a relationship between glucose level and the likelihood of diabetes? Introduce the variables. In this example, I have two variables. The first is glucose level, numerical, and the other is diabetes outcome, expressed as percentage of positive cases in each group. Both variables are treated as numerical, so we can analyze their relationship. Step 3, choose the right algorithm. So I asked what method should I use to measure this relationship? Because both variables are numerical, I mentioned before, I use Pearson correlation. This helps me measure the direction and the strength of the relationship. Step 4, explain Pearson simply. Pearson correlation gives a value between -1 and 1, interval -1 and 1, and 1 a strong positive relationship, -1 or -1 a strong negative relationship, and 0 no relationship. Step 5, you can see dataset, show data. This dataset consists of from group A to group E, and you can see the number of the glucose level and the diabetes rate in terms of percentage. So now observe the pattern. As glucose level increased from 19 to 170, what happened in diabetes rate? You can see we should increase from 10% to 85%. This shows a strong positive correlation. It means that higher glucose levels are associated with higher diabetes risk. So if R is close to +1, it means that a strong positive relationship. In next step, again, important warning. But remember, correlation does not mean causation. High glucose is strongly associated with diabetes, but other factors also play a role, such as genetics, lifestyle, physical activity, or diet. So final conclusion. So in this example, we use medical data. We had two numerical variables. We applied, because this is numerical variables, we applied Pearson correlation, and we found a strong positive relationship. This is how data science helps in healthcare to identify risk patterns. So next and final example is about the business analysis, advertising spend, and sales revenue. For example, I am a marketing analyst and I want to understand whether advertising spend is related to sales revenue. Since both variables are numerical, I use Pearson correlation. As advertising spend increases, sales revenue also increases. Using Pearson correlation, we measure how strong this relationship is. But remember, correlation does not guarantee causation. So again, step one, start with a question. Now let's move to the business. Suppose I am a marketing analyst and in a company, my question is there a relationship between advertising spend and sales revenue? Step 2, the second step, introduce the variables. In this example, I have two variables, advertising spend in dollars, sales revenue in dollars. Both variables are numerical. Step 3, choose the right method. So now I ask, what method should I use to measure this relationship? Again, what method should I use to measure this relationship? Because both variables are numerical, the correct method is Pearson correlation. Pearson correlation. This helps me understand the direction of the relationship and the strength of the relationship. Pearson correlation gives a value between -1 and 1. Again, +1 a strong positive relationship, -1 a strong negative relationship, and 0 or near to 0 non-linear relationship. So in this section, you can see data set. This is campaign A, B, C, D, E. And this is the value of advertisement spent in terms of dollar and sales revenue in terms of dollar. Now observe the pattern. As advertising spend increases, sales revenue also increases. This shows a positive correlation. It means that higher advertising investment is associated with higher sales. Step 7 again is the statistical conclusion. To measure this precisely, we calculate Pearson correlation coefficient R. If R is close to +1, it means that a strong positive relationship, and we have this. Again, important warning, but remember, correlation does not mean causation. Spending more money on ads does not always guarantee higher sales. Other factors also matters, such as product quality, market demand, competition, brand reputation, and so on. So final conclusion. So in this example, we analyze business data. We have two numerical variables. We applied Pearson correlation and we found a positive relationship. This helps companies make better marketing decisions. So in this slide, before calculating correlation, we need to ask an important question. How we can visually understand the relationship between two variables? The correct answer is scatter plots. Scatter plots. What is a scatter plot? A scatter plot is a graph where each point represents one observation. The x-axis show one variable, the y-axis show another variable. This allows us to visually explore relationships between variables. Direction of relationship is very important. When we look at a scatter plot, the first thing we check is the direction. The first thing we check is the direction. We check the direction. If points go from bottom left to top right, this is a positive relationship. Positive relationship. If points go from top left to bottom right, is negative relationship. If points are scattered randomly, we say that there is no relationship. no relationship. Next step is a strength of relationship. Next, we look at the strength of the relationship. If the points are very close to a straight line, the relationship is strong. If the points are spread out, the relationship is weak. For example, you can consider R is equal positive 0.9. We say that a strong positive. Another example, for example, the value of R is positive 0.40, 0.40. In this case, we say that weak positive. So, Pearson correlation formula. I would like to talk about the formula with an example. So, the formula sigma xi minus x bar is the mean for the observation x, for example column x, yi product times yi minus y bar. Y bar is the mean of the next column. For example, in this example, y bar is the average of completion rate and x bar is the average of SAT score. And you can see this is the divided by this formula. For example, in this data set, you can consider we have three students. This is the first SATX is the value of SAT, the score, and completion rate you can see. At the first, we calculate x bar is the average of SATX and y bar average of completion rate. And you can see the mean of x is 1100 and mean of y is 75. And after this, you can see that in this column we calculate x minus x bar for all of the students, y minus y bar for all of the students, product of this column in multiply in this column, and power 2 of this column and power 2 of this column. And after calculating the formula, you can see step 1, 2, 3, 4 is R is exactly 1. Final result R is equal 1. Perfect positive correlation. Again, formula, this is the formula. At the first, we calculate the x bar of SAT, y bar of completion rate, and then we calculate the difference between x and x bar, y and y bar, and x minus x bar power 2, y minus y bar power 2, and x minus x bar times y minus y bar. And after calculation and simplification, the correlation, Pearson correlation is perfect positive correlation and is strong and exactly 1. After applying the Pearson formula, we get R equal 1, which means a perfect positive relationship. As SAT score increases, completion rate increases perfectly. The formula measures how both variables move together relative to their average. So in this section, related to covariance and correlation, the relationship between covariance and correlation. Let's start with a question. Now let's ask an important question. What is the relationship between covariance and correlation? At the first, define covariance. Covariance measure how two variables move together. If both increase together, covariance is positive. If one increase and the other decrease, covariance is negative. So we have problem with covariance. There is a problem. Covariance does not have a fixed range. its value depends on the scale of data. So it is hard to interpret. To solve this problem, we use correlation. Correlation is a standardized version of covariance. And in this slide, you can see the relationship between covariance and correlation are equal covariance x and y divided by a standard deviation of x times a standard deviation of y. Again, this standardization does something very important. It makes correlation always between -1 and 1. Covariance tells us the direction. Correlation tells us the direction and strength. Again, covariance tells us the direction, but correlation tells us the direction and strength. So suppose that covariance is 5,000 and hard to interpret. Standard deviations are large. After standardization, correlation you can see is 0.85. 0.85. A strong positive relationship. Correlation, standardized covariance, we say that. Covariance tells us how variables move together, but correlation tells us how strong that relationship is. In this part, this is the I want to use Excel, and you want to understand how to use Excel to understand and how to apply correlation. So for example, you can consider this is a data set. Before, in the previous video, I mentioned about this. This is about the diabetes data set, PIMA data set, and we have 768 records and 9 columns. A is pregnancy, B glucose, and I is the diabetes or no diabetes. So for example, you can consider we want to understand about the for example correlation between B and for example F. We want to understand about the relationship between glucose and BMI, and we want to use Excel for calculating this. And in this case, I would like to talk about two methods for understanding the relationship between, for example, B and F, and the other things, and how to calculate Pearson correlation. For this part, for example, in this case, equal correlation, you can see the correlation between B2 column B769 comma, this is exactly column B, and for example I want to understand about the relationship between glucose and for example BMI, and BMI is F2 colon F769, and you can see 0.22 is the value. This correlation is positive, but is weak positive relationship between which one, B glucose and BMI. The other method is using data and data analysis. This package is very important. If you don't have this package, go to File, Options, select Add-ins, Analysis Tool Pack, and after selecting Analysis Tool Pack, hit the Manage and select Analysis Tool Pack, and I selected all of this, no problem. And you can see, go to data. At now you have data analysis. This package is very important and I want to use this package. So go to data analysis and you can see correlation. So for example, I want to understand the relationship between glucose, blood pressure, skin, insulin, and BMI in correlation. Okay, you need to type $B $1 column $F $769. Because I started from 1 and 1 is the text, it is important to note that you need to tick labels in the first row, and please write report in the new worksheet play and OK. And after this we have report, and this is your report. The relationship between glucose and glucose between two variables are the same, is exactly 1. I mentioned correlation is between -1 and 1. You can see all of the correlation is positive, but for example, skin thickness and glucose is near to 0, no relationship. Skin thickness and blood pressure is 0.2, weak relationship, positive relationship, and so on. This is another method and professional method to understand and calculating correlation in Excel. Again, I use two methods. One method, I use this correlation, for example, between B2 column B 769 comma F2 column F 769, and another method is using data. Package of data analysis is very important, and after this we can calculate correlation. We select correlation. For example, we want to understand glucose, blood pressure, skin thickness, insulin, BMI. We want to understand the relationship between these. I use this, and this is the report. You can understand this is the report, and it is important to note that the relationship between blood pressure and glucose is exactly such as glucose and blood pressure. This is a matrix, symmetric matrix. This is 0.15259. Exactly, you can see this is 0.15259. It means that the correlation between glucose and blood pressure is equal the correlation between blood pressure and glucose. So in this case, I use Google Colab, and we want to understand about the correlation in the Python. Exactly this PIMA diabetes data set. So at the first, import NumPy as MP, import pandas as PD. Yes. And import matplotlib.python plot as PLT. This part is about the linear algebra. Pandas is for reading and using a statistical model, reading file, CSV file, for example, and using a statistical model, and matplotlib exactly for visualization and report the result, especially for visualization we use this. The other block is reading the file. I use diabetic files. In the previous video I mentioned how to write this file with Python, and this is df data frame. The name is pandas dot read underline CSV, and the name of the file is diabetes.csv. And for showing the data set 5 records, we use df.head, and you can see we have 5 records. And after this we want to calculate the correlation. For calculate the correlation, you need to use, this is the name correlation matrix, df.correlation core, and you can see numerical only true. At the first, what does df.core CORR It calculates the correlation coefficient between all pairs of numerical columns, again numerical columns in your data set. It tells us how strongly two variables are related. So maybe your data set may contain, for example, numbers, text, and so on. Because of this reason, I use correlation numeric underline only equal true. It means that correlation only works with numbers. Is it clear? Because this is the, I mentioned Pearson, we have two numbers, and when we want to use Pearson, two numerical variables or two numbers. So because of these, numeric underline only equal true. So as now you have a table or matrix showing correlation between every pair of variables. For example, glucose and glucose are the same variable, 1 1 1, diagonal of matrix you can see this is 1. Between blood pressure and glucose is minus 0.31, blood pressure and skin thickness is near to 0. If we want to we don't need a table, but we want to understand about the relationship between blood pressure and insulin, we use exactly this formula: df blood pressure correlation df insulin, and you can see this is -1, and you can see between blood pressure and insulin, blood pressure and insulin is -1. And finally, how to use a scatter plot. For this part, plot scatter df blood pressure and df insulin. You can see exactly such as this. I use the scatter plot for this glucose level and blood pressure level, and you can see the formula. PLT is from visual for visualization and matplotlib. PLT is scatter, dot scatter, and df blood pressure and df insulin, and x label, y label, and title, and show. You can see this is the output. In this video we learned 3 examples about the education, healthcare, business application. You understood about the scatter plots and how to visualize direction and strengths, how to use Excel implementation, how to use Python programming, and how to use Pearson formula, and the relationship between covariance and Pearson formula. In next video, I will discuss about the regression and how to use regression after correlation and Pearson correlation. See you, bye.